Mhm. Okay, so I hope I'm live. Okay, so perfect. So since I'm live, first of all, hi, good evening, and so so the question or the topic that we have to discuss today is recursion, and this would be a sequel. This is something which would be in sequence to one webinar that we have already done, right? And in that webinar, we started from very basics, and that basic was we started from very basics, deciding on what recursion actually is, uh, how do we apply recursion, not from the definition of a function calling itself. We started from very basics, and we started from principle of mathematical induction. We started from mapping recursion to principle of mathematical induction. Then we started to solve very basic questions like power of a function, finding factorial, or finding sum of n natural numbers, something like this. And then we went on to get some insights. So we tried to basically we tried to ponder on those insights, and then basically we went on to solve one good question, that was Tower of Hanoi. And we did Tower of Hanoi for almost 30-40 minutes. We took a lot of time to basically solve Tower of Hanoi. So my first request to you would be, I will quickly summarize whatever I had discussed in that webinar, whatever insights that we had got in that webinar. But my quick advice to you would be that even if you want to learn it properly, I would advise you to first go through the earlier webinar on Coding Ninjas. On Coding Ninjas YouTube channel, you can just go there and just type recursion, and probably the search result would come either on the top or on the second or third, right? So I'll explain you. I'll quickly summarize whatever we discussed last time. I'll do a quick recap, and with the help of that recap, you would be able to understand whatever we learned last time, and we would be able to learn something new this time, right? Okay, perfect. So right. So let me quickly share my screen then. So before starting with the webinar, this is the webinar that I was talking about. Yeah. So this was the webinar which we did on 28th May, and it started with very basics like introduction to recursion through principle of mathematical induction. Then we talked about void recursive functions and non-void recursive functions, and then we talked about Tower of Hanoi uh, and all those things, all those variations that that we have around Tower of Hanoi, right? So one quick thing that I wanted to ask from you all is that how do you want this webinar to be? Do you want things to be taught from very basics, or do you want me to take things forward from where I had up to which I had taught last time, right? So just a quick hello. I just wanted you to give me a quick brief that how exactly do you want things to be taken forward? Do you want me to start from very basics? Do you want me to start from ABC of recursion, right? Do you want me to start from basics, or can I assume that can I assume some things? Okay, 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 okay. So it's pretty clear that we have to basically go from the very basics. Yeah, sure, sure, sure. Okay, perfect. So I'll take quick 15 to 20 minutes to talk about those basics, and then basically we'll go with these things. Okay, perfect. Thank you. So we'll do that. We'll do that. Okay. So, okay, got it, got it, got it. I'll start from the very basics. Don't worry about these things. Okay. So, if we talk about recursion, one thing that I just wanted you to focus on is that recursion is something that we all know about. It's something as function calling itself, right? We know recursion as function calling itself, right? We know how function calling works, and we know recursion as a function which calls itself, and it uses the function calling mechanism and it uses the same function calling mechanism that basically functions use. So we know recursion this way, but we will learn about recursion in a different way, right? So let's talk about something like this. Like for example, if I'm given f of x equal to x square plus 4, let's suppose something of this sort is given to me, right? Now, do you have an exact mapping of this function in programming? We have, right? We have programming functions, right? How do the programming functions look like? Programming functions look something like this, right? So if I convert this function into programming, so I would write something like this, right? I just wanted you to have a quick overview of what we discussed last time. So this is how the programming function looks like, right? X into x plus 4, right? You give a value of x, you will get a value of y, you will get the value of fx, exactly the way it works in mathematics. Now, you see that addition, multiplication, division, everything is mapped to programming. Similarly, recursion is also mapped to something in mathematics. Recursion is mapped to something which is called as principle of mathematical induction, right? So in principle of mathematical induction, what happened in principle of mathematical induction was there were three steps, right? So first, let's quickly talk about these three steps. Principle of mathematical induction was used to prove something, was used to prove one formula, one expression. So let's talk about very simple formula. Let's talk about this formula called sum of n natural numbers. So I know that the sum of n natural numbers is something like this. If I'm given expression of n natural numbers, it would be equivalent to n into n plus 1 divided by 2. This is the expression that I know, right? Now, by principle of mathematical induction, we have to prove this, that this is true. So what we do is we have three steps. First is the basic step. First is the trivial step. First is the trivial step. So let's name it trivial step. Very basic step, right? So first is the step for which we have to basically, we know that the answer is pretty well known. So for example, let's take n equal to 1. For n equal to 1, the left hand side would become 1 only. And what would right hand side become? Right hand side would become 1 into 2 divided by 2, which would be equivalent to 1 only. So for n equal to 1, I have proved that this formula holds true. Now what I will do is, now I will go to a assume step. You all know that there was an assume step, right? So in assume step, what we used to do was we directly used to assume that this formula holds true for any n equal to q, any n equal to k, right? So we just used to assume that this formula will hold true for any n equal to k. So let's quickly assume step. Let's quickly write the assume step. So by assumption or by the assume step, what I can write over here is that this formula holds true. कुछ सोचा नहीं और कुछ ये नहीं प्रूव नहीं किया, बस अज्यूम कर लिया डायरेक्टली दैट दिस फॉर्मूला विल होल्ड ट्रू फॉर n इक्वल टू k. यही करते थे पीएमआई में, राइट? और उसके बाद वी यूज्ड टू राइट अ टू प्रूफ स्टेप, राइट? व्हाट यूज्ड टू हैपन इन टू प्रूफ स्टेप्स? नाउ सिंस n इक्वल टू 1 is proved, n equal to k is assumed. Now you have to prove for n equal to k plus 1 using the first two steps. So fatafat say, let's try to prove it for n equal to k plus 1. So what would be the left hand side become for n equal to k plus 1? It would become something like this, right? And हमें इसको prove करना है, right? Right hand side में क्या बन जाएगा? Right hand side में it would become k plus 1 into k plus 2 divided by 2. This is something that we have to prove. Let's talk about this much of part. Since we have assumed that this expression is equivalent to k into k plus 1 divided by 2, so what we can do is we can take this much amount of expression and we can directly write k into k plus 1 divided by 2. And we can add k plus 1 over here. Now, if I take k plus 1 common, so if I take k plus 1 out of this expression, I would be left with k by 2 plus 1, which is nothing but it's exactly equivalent to k plus 1. And then this 2 goes this side, it will become k plus 2 divided by 2, which is exactly equal to right hand side. So this is how I prove that this expression holds true for all the natural numbers. If this true two proof step is complete, then I can say that this formula holds true for all natural numbers. it holds true for all natural numbers. ये मैथमेटिक्स में हम करते थे, right? And I think I don't have to talk about this part कि अगर k का अज्यूम करके अगर मैंने प्रूव कर दिया k+1 के लिए, तो वो सारे नेचुरल नंबर्स के लिए होल्ड ट्रू करता है. इसका रीजन बताने की तो जरूरत नहीं है ना. Yeah, sure, Avinash. I'll talk in English only. So I just wanted to talk about one thing. That I think I don't have to talk about this thing. You already know about this part. That why we are assuming for k, and basically why the two proof step is for k+1, and if I have proved for k+1, why it is valid for all the natural numbers. I think this much is clear to you, right? Okay, so I hope this much part is clear to you. Now, let me focus on the part that I want you all to focus. Okay, Arpan is saying that he's not aware why after proving k and after assuming k and k+1, why it holds true for all the natural numbers. Arpan, it's pretty basic. Yeah, right. So you prove for n equal to 1, and then you assume that if k is true, then you prove that k+1 would be true, right? You prove this part. N equal to 1 is true. So with the help of this formula, you can prove it for n equal to 2. Then with the help of this formula, you can prove it for n equal to 3, right? Because n equal to 2 is true, n equal to 3 would also be true. Similarly, using this formula, you can prove it for n equal to 4, and similarly you can prove it for n equal to 5, so on and so forth. You can prove it for all the natural numbers. That's why this formula holds true, right? So this was something, right? The thing that I wanted you to focus over here is that there are three steps. One is the trivial step, right? For which we already know what needs to be done, what needs to be proved. One a value of n for which I know that the left hand side is equal to right hand side. For one which I already know that this formula holds true. Then the other step that I want you to focus over here is assumption step. Yeah, right. And the last step that I want to talk about is the two proof step, right? So these are the three steps that we had. Now let's talk about solving this problem using recursion. Let's try to solve this problem using recursion. So I have to, what I have to do is I have to write a function. So if somebody tells me find the sum of n natural numbers using recursion, so that means he will tell me that write this recursive function. What is that recursive function? He will say that the function would be returning int, and over here I would say that let's name the function func, and let's give the input as int n, right? Something as basic as this, right? Somebody would tell me that just find the sum of n natural numbers, just complete this recursive function. So what I will do is I have to remember that this trivial step, assumption step, and two proof step, don't forget about these steps, right? So what I will do is I will basically first try to think it this way, that I will say that I have to have an expectation, right? Or let's talk about the problem over here. What is the problem over here? Problem over here is that I have to basically write this function, func of n, which is to find the sum of n natural numbers, right? Now I will assume that a sub part of this problem, and I would assume that the answer to this sub problem is already known to me, that the answer to this sub problem would automatically come to me. So I would assume that a sub part of this problem would already give me the solution, right? So I would assume that I will take a sub part of this problem, which is func of n minus 1, and I will assume that the answer to this sub problem would automatically come to me, right? So this is something that you have to assume, right? So take a sub problem and automatically assume that the answer would come for it. So I would assume that if somebody tells me that func of n is the problem and you have to find sum of n natural numbers in it, so I would assume a subpart of the problem, which is func of n minus 1, and I would assume that the answer to it would automatically come. And let me keep the answer over here. Let me keep the answer over here, int answer, right? The answer of first n minus 1 natural numbers will come into answer, right? That's something that I want to talk about. So just assume, this is the assume step that I wanted to talk about. Just assume on a smaller set. Assume, let's suppose the sample space your problem for your problem is n. Assume on a smaller sample space. Assume on n minus 1. Assume on n minus 2. Assume on n minus 3. Assume that the answer to the problem will already come. Assume that you have written func n minus 1 and your answer will automatically come. Right? So after your answer has come, let's suppose the value of n is equal to 5. What is the answer for sum of first 5 natural numbers? It is 15, right? So you have to find this answer, but you don't know this answer. So you are assuming that the answer of n minus 1 would automatically come. The answer of n minus 1, what is the answer of n minus 1? The answer of n minus 1, that is the answer of first 4 n natural numbers is 10. You have assumed that the answer would come, and that answer is coming into this variable called ans. Now 10 has already come. What you have to do is you have to find 15. What I need to do to find 15? What is one calculation that I have to do to basically find 15? The only calculation that I have to do is I have to write this step. I have to write return answer plus n. This is only thing that I have to do, right? Once I have done this part, my sub problem would basically solve the problem. So I have to create a problem, I have to create a sub problem, I have to assume that the answer to the sub problem is already known, and then basically I have to do some work on the problem. I have to do some work on the sub problem's answer to solve the problem. So that's something that I have done, right? So this is the first step that you have to do, right? So you have to basically create problem, create sub problem, assume that the answer to the sub problem would already come, and from that you basically have to find the answer to the main problem, right? After that, what you have to do, right? There is a small problem with this function. What is the small function problem with this function? The small problem is that it will never stop. You know about recursion, right? You know about function calling. Let's suppose the value of n is equal to 5, right? So over here, I will basically make call to f of 5. Then the first line will get executed and it will make call to f of 4. That's how function calling works. First line will get executed, it will basically make call to f of 3. Then first line will get executed and it will make call to f of 2. So on and so forth. First line will get executed, it will call to f of 1. It will make call to f of 0. So on and so forth. It will never stop. It will go to f of n minus 1, then f of minus 2 and f of minus 3. It will never stop, right? There is a limit to stack, and when that limit or the memory get exhausted, when the stack frame is exhausted and no more stack blocks can be added, at that point of time it will stop, right? So but what we will get, whether we will get the answer, no, we will not get the answer. We have to stop it somewhere. So at this point of time, this is the point of time where our trivial steps comes into play, right? We have already seen where a to prove step is. We have already seen where a assume step is, right? I think you can see where the assume step is. This sub problem is our assume step, and the to prove step is the problem that we have, right? So now we have to find the trivial step. So you take this function. There is only one thing which is missing in this function. We have to stop this function somewhere. So take a small example. So take a small example. So let's suppose, let's take a small example and basically let's take n equal to 5. And now let's dry run for this. So if I dry run, what I would find over here is that this is the stack frame that I have, right? So over here, what I can see is that there is something which basically, which will start from f of 5. And there is a local variable which would be created. The value of the local variable would be n, and the value over here would be 5. The first line will get executed and it will make call to f of 4, right? It will create a local variable. Again, this local variable would be created. And over here, the value of the local variable would be 4. The same value n, but it will be created again and again because it's a local variable. So the variables are created again and again. And as soon as the first line gets executed, it will make call to this next block, and next frame gets attached into the stack frame. Over here, it will make call to f of 2, right? The first line gets executed, it will make call to f of 1. So what we have done over here is we are doing a simple thing. We are telling that for solving f of 5, please make a call to f of 4. Once you get me the answer of f of 4, I'll quickly find the answer of f of 5. That's something that you have done. F of 4 is saying that I will find the answer once you find the answer of f of 3. F of 3 is saying once you find the answer of f of 2, I will find the answer. So on and so forth. It's making call to its smaller subparts. It's making call to its smaller sub problem. But there is one part for which I don't have to create smaller parts. You already know that the answer for f of 1 is equal to 1. The sum of first one natural number is 1, right? So you don't have to make further calls. You can directly return its answer. So that is called the trivial step. The trivial step for which you don't have to go ahead, for which you know the answer. So whichever is your trivial step, write it over here. If n is double equal to 1, then basically you don't have to divide it into uh, further sub problems. What you have to do is you have to directly return 1. Its answer you have to directly return, right? Your answer you have to directly return, right? So it will directly return 1. Whatever it will return, it will be caught by whom? It will be caught by the answer variable in f of 2, right? So the first thing that you have to focus on is as soon as it returns, it will basically swipe off f of 1, right? This thing gets swiped off from the stack frame. As soon as the return happens, it gets swiped off from the stack frame. Then the onus, the execution, the complete responsibility comes to f of 2. That is what is being executed currently, and whatever it returns, it is caught by answer of f of 2, and what it catches 1, and what it will do is it will add 1 to its n. What its n? It's 2. 2 plus 1, it would return 3, and it would be caught by this. What it would do, it will catch the above value, add 3, return 6 below. What it will do, it will catch 6, add 4, and basically return 10 below. What it will do, it will basically add 10 with its n value, and it will return 15 to the main function, to the calling function. That's how we have to do, right? That simple thing that we have to do, right? So you have to dry run your problem sub problem code on a small example. Then you have to find the trivial case, the case where you have to stop your recursive calls, right? And after you plug in your trivial case, your code would be completed, right? So that's your code that you have to write, right? And you have to see this part, that which part is your trivial step. You have to see this part, which part in this function is your trivial step, which is assumption step, and which is true proof step. So the problem which is given to us, for which we have to write the recursion function, is a true proof step, and the sub problem for which we assume that our answer will come is the assumption step, and the trivial step is the base case. Trivial step is the smallest problem size for which we already know the answer, right? For which we already know the answer, right? So these are the steps that you have to focus on, right? So I just wanted to ask you a quick thing, that were you able to understand whatever I was talking about so far, right? If you have any questions on the questions that I have talked about so far, just let me know in the comment section, right? Just let me know in the comment section if you have any doubts on the questions that I have talked about so far, all the things that I have talked so far. Uh, yeah. Any questions? If you have any questions, just let me know in the comment section. Yeah. Okay. Yash is saying he's not able to come up with logic for the recursive problems. Yash, that is exactly what we are talking about over here. That how do you come up with the solutions to the recursion problem, right? You have to make sure that your recursion problem is solved in this sequence. First, you have to see the problem. What is the problem which is given to you, right? Then what you have to do is you have to divide your problem, right? What you have to do is you have to assume, right? So I'll basically name it sub problem. Then you have to assume that the answer to your sub problem would automatically come, right? Assume answer to sub problem, right? And from the answer of sub problem, solve the problem at hand, right? Solve the problem from the assumption step, right? That's something that you have to do from the assume step. Whatever answer that you get from the assume step, solve the problem, and then dry run to find the base case. Dry run to find the base case. After you find the base case, just have to plug in the base case and then your function would be complete, your question would be complete, right? Right. Perfect, perfect. I could see a lot of no doubts over here, so I would basically talk about other questions. Let's move to the other question. Yeah, perfect. Perfect. Somebody is asking to run this program in any ID. I think we have dry run. I think Abhishek is asking to dry run this program in any ID. This is very basic program. I don't want to run this on any ID. It's pretty straightforward and it's pretty standard problem. So what I want you to focus on is, I want to focus on these steps that I am talking about, and let's try to apply these steps on next problem that we have. Right. So the next problem that we have over here is, in the last question there was only one variable in the recursive function, right? So over here, what I will do is I will take two problems. I will take two problems. I will take two variables in my function. So let's say that somebody tells you find, let's take that find x to the power n, find x to the power n, and let's say x to the power n, you have to find x to the power n, and let's assume that somebody gives you 2 and 5, so you have to find 2 raised to power 5, that is 32, right? So this is the recursive functions that you have to write. Think it this way: find what is the problem, find what is the problem, and then find what is the sub problem, right? Assume what should be a sub problem, right? Yeah. Arpan, don't worry about what is excessive recursion, what is tail recursion, and whatever all these things are. Don't worry about it terms. I would request you to focus on. I would request you to focus on the concepts. Try to solve more and more problems. Right. Once you solve problems like Sudoku, crossword, word break, and all these problems, then you would automatically understand recursion. Right. So let's talk about this problem that we have in our hand. The problem that we have in our hand is basically we have to write this function. We have, and this function should return x to the power n. So just let me know. How do you think that what should be the problem to this function? What should be the sub problem to this function? I just want to give this question to you. What do you think the sub problem should be over here? A problem, obviously I know that problem is find the power, find this power x to the power n, find this, right? Yeah, Krishna, we would be solving more problem, we would be solving more problem, we would be talking about DP problems as well, right? I would be talking about one DP problem as well. What exactly is dynamic programming, I would be talking about that as well. So uh, what I want you to focus over here is, yeah. So Arpan has correctly answered. Deepak, to repeat what I was asking is that problem I know, the problem is find power x to the power n using using recursion. What should be my sub problem? So my sub problem, as people are rightly mentioning, my sub problem would be power x comma n minus 1. So this is something that I will be keep my sub problem, and I would assume that the answer to this sub problem would come, right? So let's quickly write and let's assume that the answer to this sub problem would come. So this would be power x comma n minus 1. As simple as that, right? So now let's suppose somebody gives you 2 comma 5, and you assume that the 2 comma 4 would the answer to 2 comma 4 would come. So the answer would be 16, and you have to form 32. What should you do so that from 16 you are able to form 32? Right? The simple thing that I have to do is I have to just return answer into x. I just have to find x into x raised to power n minus 1. I'll get x raised to power n. Right? This is something, this is very simple thing that I have to do. Right? So perfect, perfect, perfect. Now the next step that I have to do is I have written the bare bones code. I have written the code without any you can say without any base case, without any trivial case. Now this code would basically give me a stack overflow error. It will not stop anywhere, so I have to stop it somewhere. For stopping it, what I have to do is I have to add a base case. I have to write a recursion terminating step. So obviously what I'll do is, let's take for example 2 raised to power 5. Let's try to solve it on a stack frame, right? I'll quickly do that. So first the function that would be called is 2 comma 5, right? And then the next function that would be called would be 2 comma 4. It will make call to 2 comma 3. You have to just tell me where exactly do you want to stop this part, right? So at 2 comma 2 you are saying that don't stop over here as well, but you are saying that at 2 comma 1 you have to stop. So you are saying that if n is double equal to 1, at that point of time you should stop. We already know what should be the answer to 2 raised to power 1, and you are saying that the answer to this should be 2, right? So if n is double equal to 1, you are saying that return x, right? Okay, I believe you, and I put this base case over here. Then this would directly return me 2. And what I'm doing over here is, whatever answer I get from above, I would multiply x with it. So this would become 4. It would return 4 over here. It would multiply another 2 over here, and it will return 8 below. It would multiply 8 with 2. It will return 16 below. It will multiply 2 with 16, and it will return 32 to the main function. So my question is complete, right? My question is complete. But let's suppose somebody tells you find the value of 2 to the power 0. If somebody tells you find the value of 2 to the power 0, what will you do then? So Arpan has rightly mentioned there should be another base case over here, and that base case I am writing over here is that if n is double equal to 0, then you have to return 1, right? So these kind of things, these are some corner cases that you have to take care of, right? But I hope you have got the idea what I was talking about and how exactly should we do these kind of questions, right? Now let me talk about Tower of Hanoi. Let me quickly move to the next question that we have, which is Tower of Hanoi, right? I hope you have the idea that how exactly should we basically talk about and how exactly should we solve these questions. In this question, we had two trivial cases, as rightly it was mentioned by others today. This is something which is called as linear exponentiation, right? This is something which is called linear exponentiation because I was going from n minus 1, n minus 2. I was going linearly. There is something called as binary exponentiation as well, which I would leave to you for exploration, I would say, right? So whatever you're talking about, right? Whatever you're thinking about, you must be thinking about that a problem is given to me. If let's suppose n is given to me, then what I have to do is I have to make a sub problem and I have to make a call to n minus 1, right? Always you're thinking that I have to decrease it by 1. I have to decrease the sample size by 1, right? It will not, it's not universally true, right? You can make any sub problem. You just have to find a way. You just have to find the solution from the answer of the sub problem. If you are able to find the solution to the main problem from the answer of the sub problem, then you are good to go. You can assume anything. So in linear exponentiation, what we did was we assumed the answer on n minus 1. But in binary exponentiation, what we do is we assume the answer on n by 2, right? Let me quickly showcase you what we exactly do over here. So let's suppose somebody tells me that find the answer for 2 to the power 8. So what I'll do is I'll ask him that tell me the answer of 2 to the power 4. So it will tell that obviously the answer for 2 to the power 4 is known to me and it is 16. How do I calculate 2 to the power 8 from the answer of 2 to the power 4? You just have to multiply the answer twice, right? 16 into 16 and I'll get 256, which is 2 to the power 8. So you have to simply assume, right? Whatever you want to assume, you can assume. Similarly, let's suppose if somebody tells me find the answer of 2 to the power 5. I would say find the answer of 2 to the power 2. It will say the answer of the 2 to the power 2 is 4. How do I find from 4? How do I find 32? So I would say that 2 to the power 5 is equivalent to 2 to the power 2 into 2 to the power 2 into 2, 2 to the power 1. So if something is odd, I have to multiply 2 to the power n by 2 twice, and then I have to multiply it by x again. So the answer to 2 to the power 5 would be 4 into 4, and then I have to multiply x again, right? So now I'll get 32. Or for example, if somebody tells me to find 2 to the power 15, let's take this example, right? So if somebody tells me to find 2 to the power 15, so I would say that the answer to this would be 2 to the power 7, 2 to the power 7 into 2 to the power 1. Or I could say 2 to the power n by 2 into 2 to the power n by 2 into 2 to the power 1. If it's even, I just have to multiply it by 2 to the power n by 2 into 2 to the power n by 2. So that's exactly how we solve these problems. Assumption is dependent on you. Assume whatever you want to assume, right? Try to solve problem with these assumption steps. Try to solve these problems using these assumption steps, right? Now, let me basically take you to the Tower of Hanoi problem, right? So, perfect, perfect. Deepak Singh is saying that multiply the number by itself and divide the power by 2 every time. That gives you log and time complexity. Yeah, exactly. The point that Deepak is making over here. So that is something which is called as binary exponentiation. Now I would want to take you to another problem. Now let's test whatever steps that I have been talking about. Now let's test our logic. Now let's test our hypothesis. Let's test our common logic that we have built on more problems. So let's talk about Tower of Hanoi, right? So before moving on to Tower of Hanoi, I just want to see and I just want to ask you if you are able to follow me. If you have any doubts, then just let me know in the comment section. If you have any doubt, just ping me in the comment section and I would take it. Yeah, lot of comments like okay and wow and nice. If you have any doubt, just put it in the chat section. I basically want to talk about this Tower of Hanoi example, and then I would want to tell you about the plethora of or the myriad ways in which recursion can help you in solving problems. Right? I want to take you to that step as well. But before going to that part, just let me know if you're able to follow me. Okay, perfect. Arpan is saying that he is following me. Okay, okay, perfect. Okay, just one comment, which is of Arpan. I would like some more comments. If you can quickly post a few more comments. Okay, okay. Okay, perfect. So Deepak and Ankit has also posted. So basically, let's talk about Tower of Hanoi now. So what happens in Tower of Hanoi is that you're given three rods, right? So there is a rod which is given to you over here. There is another rod which is given to you over here, and basically there is another rod which is given to you over here, right? So what happens over here is the first rod is named A, right? And the second rod is named B, and this rod is named C, right? So over here, let's give them proper names. This is the source rod, right? And this is, you can say, this is the auxiliary rod, or this is the helper rod, or this is the secondary rod, which is just kept in between to help the movement of transfer of disk. And this is the destination rod, right? So I have three discs over here. This is the biggest rod, and let's name the biggest rod, biggest disk. Sorry, rod is this, and this is my disk. Sorry. So the things that I have kept on the rod is disk. So I have a bigger disk whose number is 3. And then basically, let's talk about more disk over here. There is another disk of size 2, and there is another disk of size 1. What I have to do is I have to take this disk and I have to move all these disks to destination, right? There are a few, you can say, there are a few constraints on it. So we have to move these disks from source to destination following the rules. What are the rules? Let me quickly talk about those rules. The first rule that I have is that I can only move one disk at a time. You cannot take 2 disks or 3 disks at a time, one disk at a time, right? And the second rule that I have is that you can only keep smaller disk over a larger disk. Smaller disk can be kept only over a larger disk. At the base, you should have a bigger disk, and over that you should basically have a smaller disk. Over that you should have more smaller disk. So that is something you have to take care of. These are the two rules that are given to us, and the question is given to us that you have to basically move all the disk from source to destination, right? And when you are moving one disk, print the instruction. So let's suppose you are moving the first disk from here to basically to B. So you have to write that move A from B, move from A to B, move the disk one from A to B. So this is something that you have to type. So you have to move all the disk from A to destination, from source to destination, and you have to print the instructions as well. And this all has to be done using the rules, right? So all of this has to be done following the rules. Now let's talk about this problem. If our faith, if our problem, if our subproblem, if our assumption, if our two proof steps work on this, then I can say that this recursion step or the logic that we are using is really strong, right? If it works on this. So as usual, what we have to do is we have to first talk about the function that we have to write. So somebody tells me that it would be a void function. I just have to print. So somebody tells me that this is the function that you have to write, right? String, you are given with string source. The value of the string source would be A to begin with. And you have to basically write the destination string over here, which is C. And then I have string auxiliary, which is B to begin with, and the number of disks that I have to move. So this is the function that I have to write. There are four things which are given to me. First thing which is given to you, uh, first thing which is given to you is source, then the destination, then the auxiliary, and then the intent. Right. So these are the things that I have to that I have been given. Right. Now you have to write the recursive function. So obviously the first thing that I have to do is talk about the problem, and then I have to talk about the subproblem. Problem, obviously I know about the problem is obviously this is the problem that I have to move end disk from source to destination role, or I can say I have to move three disk from A to C, and what I have to do is I have to use auxiliary, I have to use B, and while I am doing that I have to follow some rules, and I have to print instructions of that. So I have to print instructions of moving end disk from source to destination using auxiliary. I have to print instructions of moving three disks from A to C using B, right? So this is something that I have to do. This is the problem that I have, right? Now let's talk about subproblem, right? So subproblem is something that we need to talk about. Subproblem is something that I want you to focus on. Can you talk about subproblem? Can you think of subproblem over here? Let me again talk about the problem. The problem is that print the instructions to move three disks from A to C using B. This is the problem that we have, right? Find the subproblem to it. What would be the subproblem to it? Just try to find the subproblem to it, right? Arpan is saying that print instructions for two disks. Pretty good, I would say. But what I need to do is, I need to basically, what we did was, when somebody told me that find the answer for 2 to the power 5, right? So what we did was, we know the answer of 2 to the power 5, which is 32. Subconsciously, we knew the answer for 2 to the power 5 was 32. So what we did was, we took 2 to the power 4 as our subproblem, and the answer to it was 16, and then we multiplied it by 2 and we found the actual answer. So similarly, we should know the answer to the problem for one problem. So let's find the answer for n equal to 3. Let's quickly find the answer for n equal to 3, right? So somebody has written the answers. So a user with the name Shabnam has written some answers. Gautam has also written some answers. So let's talk about these things, right? So let's try to frame the answer first, and then we'll see whether our assumption step can be kept on 2 or not, whether the assumption step can be kept for n minus 1 or not. Let's talk about this, right? So over here to begin with, I have 3, I have 2, and I have 1, right? And this is A, this is B, this is E, this is C. You just have to solve the problem. You don't have to do anything. So what I would do over here is I would basically first take 1 and I would move this 1 from A to B, right? Let's move one from A to B, right? So I'll move this thing from here to here, right? Then I'll take 2 and then I'll move it from A to okay, sorry, I did a small mistake, right? So this is my destination that I have. This is my auxiliary and this is my source. So what I'm doing over here is I'm taking this disk and I'm putting the disk to destination, right? So let me quickly put it to destination. So C is my destination, right? So let me quickly put it to destination. So I have taken this part from here and I'll put it to destination. So then what I have to do is I have to take the second disk and I'll take it from A and I'll keep it at B, right? So I've taken B from here as well, 2 from here as well, and I've kept 2 over here. Then again, what I'll do is I'll again take 1 from here and I'll move it over here, right? And I'll keep 1 over here, right? So what I've done is I've taken this disk from destination and I have kept it at auxiliary, or I have kept it at B, right? So now what I can see is that my destination is completely empty. My destination is completely empty. As you can see, my destination is completely empty. Both the disks have been moved to B. Now what I'll do is, one thing that I'll do is I'll take the third disk and I'll keep it over here. So one thing that I'll do is I'll take the disk from A and I'll keep it to the destination, which is 3. So I'll move it from A and I'll take it to C. Now let's talk ahead. Now let's talk ahead. What is the current scenario that I have? Let me quickly talk about the current scenario. It has been a lot of scribbling, so you're not able to see it properly. Let me quickly draw it again for you. After these 4 steps, this is the source for me, this is the auxiliary for me, and this is the destination for me. Destination has 3, auxiliary has 2 and 1, right? Now what I'll do is if I want to bring these disks over here, so I'll take 1 from here and I'll keep it over here. So let's quickly write, let's move 1 from the auxiliary to source. What was the auxiliary? Auxiliary was B, and let's take from auxiliary and basically take it to the source, right? So source is A, source is empty. Then what I'll do is I'll take the second disk and I'll take it from here and move it to destination, which is I'll take it from the auxiliary and I'll move it to destination. Destination is named C. So I'll take it from B and I'll move it to C, right? And then what I'll do is I'll take it from here and I'll move it over here. So 2 is already here and I'll bring 1 also here, and this completes my movement. So this completes my movement, right? Right? So first we have to solve this problem, right? First we have to solve this problem like this, right? And after we have solved this problem like this, then we can talk about something else, right? For n equal to 3, I have already seen the solution. Now let's quickly write for n equal to 2, and then let's see if it can really solve the problem or not, right? So let's quickly talk about n equal to 2. There are only 2 disks. Let's quickly try to solve it, right? So for n equal to 2, there are only 2 disks and you have to quickly solve it for me, right? So this is auxiliary, this is source, and this is destination. The name of this would be A, the name of this would be B, and the name of this would be C. And there are only 2 disks, right? So there are 2 disks over here and there are 1 disk over here, right? So I have to move both these disks from here. You have to move it to C. So it looks pretty simple. I would take it from here and I will keep it over here first. Then I'll take it from here and I'll keep it over here. Then I'll take it from here and I'll keep it over here. Looks pretty simple, just 3 steps, and I've taken this part from here and I moved over here. So those 3 steps would be: take 1 from A, keep at B, take 2 and basically take it from A and keep it at C. Then what you have to do is you have to take it from B and you have to keep it at 1. Right? Pretty simple. For n equal to 2, you can see the solution. This is for n equal to 2. And this is for your n equal to 3. This is something now you have to figure out what should be my base case, what should be my sub problem. Can my n minus 1 solve my n? Can n equal to 2 solve n equal to 3? There are three variables over here. Sorry, there are four variables over here. There is something called as source, there is something called as auxiliary, there is something called as destination, and there is something called as n. So there are four variables. It's not that simple. It's not that something which basically, which you would say that there is only one variable. I want to solve it for n equal to 3. You solve it for n equal to 2, and then I'll do something and I'll solve it. Right? Right. So you have to find some pattern, right? For n equal to 3, try to solve this problem for n equal to 2. Try to solve the problem, for n equal to 3 from the answer of n equal to 2, right? Deepak has correctly talked about, Deepak has, you can say, has hit the bullseye. Deepak is saying that in general, what we can say is that we can make two recursive calls, right? So he's saying that you have to solve this problem, Tower of Hanoi, move n disk from A to C using B, and how many disks are there? There are n disks, right? So he's saying that look closely, right? You have to move 3 disks from A to C using B, right? You have to move n disk. So this n equal to 2 solution, right? I can see somehow it's coming over here, right? There is some n equal to 2 solution over here. Then I can see that there is another n equal to 2 solution over here, right? I can see that basically there is n equal to 2 solution which looks very similar to this, and there is another n equal to 2 solution over here which basically looks very similar to this, and then there is something which is done for n equal to 3, right? So let's try to find what exactly is written over here. So I know a great amount of deal about this, right? What is this? This is the answer for moving 2 disk from A to C. It is moving 2 disks from A to C, and what it is using? It is using B. So if you write A and you write B over here, and if you write C over here, then this would be the output, right? You can move 2 disks from A to C using B, right? If you want to bring this output, what you have to do is you have to closely see what is the things which are changing. In place of C, I have B over here. In place of A, I have A over here. In place of B, I have C over here. So I think the first sub problem should be I have to move n minus 1 disk, or I have to move 2 disk from A to B using C. So this is the first sub problem that I have to write, right? This is Tower of Hanoi. You have to move n minus 1 disk from A to B using C, right? So this is the sub problem that I have to get. And then basically one work I have to do myself. This work I have to do myself. And then this is another sub problem that I have to basically solve, right? So Arpan has correctly mentioned that that this is something that you have to write. This is, then you do your work, print the work for nth disk, move n from A to B, right? This is something that you have to do, not B, from A to C. And then after that, what we have to do is after that, we have to basically do this part. What is this? I'm taking 2 disks from B and I'm moving it to C using disk A. So I would write Tower of Hanoi, move them from B, take them to C using the disk A. And basically, how many disks I have to move? I have to move n minus 1 disk. Right? So this is the faith and expectation. This is the problem and the sub problem part that I was talking about. This is something that I was talking about. This is my sub problem 1. This is my sub problem 2. This is the small task that I am doing. And with the help of these two things, I have solved the complete problem, right? Now we have to dry run this. right? We have to dry run this, right? So, do you want me to dry run over here? Or the other thing that you can do is you can refer this video that I have made over here. And over here, I have elaborately talked about Tower of Hanoi and how exactly do we dry run and what exactly do we do over here, right? So one way is that if you want me to dry run right now, I can dry run it also. But I would recommend you to go through the dry running part from this video, which I have already made on 21st May, on the webinar which I have done on 21st May, right? What we can do is we can talk about how do we practice more on recursion, right? We can talk about that as well, right? Just let me know your thoughts on this. Do you want me to dry run, or you can dry run yourself and you can find the base case yourself? Is this much amount of explanation enough for you, or do you want me to work on this problem more? Okay, Gautam is asking me to dry run. So okay, sure. Okay, Ashish is also asking, so let me quickly do that part. Okay. So if you want me to dry run, let me quickly create some space for myself, and then I'll do this part. And then let me quickly keep this code at the end, right? And okay. Deepak is correctly mentioning this part. Yeah, yeah. So a lot of people are asking about dry running part. So let me quickly do that. Shabnam, Deepak, and Vinod, Pramod. Let me quickly do that. I won't take more than 2 to 3 minutes, or about 5 minutes, not more than that. Yeah. Then I'll come to talking about how we can practice recursion more and what exactly are the resources for recursion. Right. Let me quickly do that. So for that, what I need to do is I need to write this code pretty clearly, and then I would be able to write code or dry run this part. So let me quickly write this code very neatly. So the question that was given to me was that you have to move three disks from, rather than writing three, I should write n over here. You have to move n disk from A to C using B. So I wrote over here that the answer to this would be first move n minus one disk from A to B using C. And after n minus one disk are moved, now there is only one disk which is left at A, which is the largest disk. Now what you should do is you should move the largest disk. From where? You should move it from A, and you should move to destination directly because destination is also empty, and you should basically move this disk. After that, what you should do is you should take the disk, remaining n minus one disk from B, move it to C using the empty block, empty rod A, and you should do it for n minus 1. So this is the complete block that I have. Let's quickly dry run this part, right? So let's name it at A, B, C, and 3. Let's quickly do that. So since there are two recursive calls, this is first recursive call and this is second recursive call. So what I will basically do over here is I would write that this is the first execution call that I'm doing over here. This is the first line that I'm executing over here. This is the second line that I'm executing over here, and this is the third line that I'm executing over here. I'll quickly write about that over here. So first I have to execute the first line, right? In first line, what happens is you have to see this thing remains same. This thing comes in between and this thing goes over here and this thing becomes n minus 1, right? So you have to see this part. So the source becomes A, right? And the destination becomes B. There is swapping between these two values in the first call, right? So this would come over here and this would come over here, and 2 would come over here. Now the first recursive call would be made. The first line would be executed for this, right? So what I would do over here is I will again do swapping happens in the first recursive call. So I would write A, B, C, comma 1. Then for this function, again, the first recursive call would be made. So what I need to do is I can solve this question for n equal to 1 also, or I can make a recursive call to A, C, B, comma 0, and then I can proceed further. But I think I can solve this question for n equal to 1. Let's try to solve this question at n equal to 1 only. So let me quickly explain you the problem. For n equal to 1, what would be the solution? It's pretty simple. If A is given to you, B is given to you, C is given to you, and there is only one disk, and you have to move it from A to C, what would be your answer? It's pretty simple. The answer is pretty simple. You have to just move the disk from A to C. Pretty simple, right? So that's something that you have to do, right? So what I would say over here, that the answer to the base case is pretty simple, right? You just have to move the one disk from A to C, right? So the base case, I think the base case, I found base case. So you should write over here, if the n is equal to 1, just write the print statement that move the first disk from A to C. That is something that you have to do. So I've written that. Then I'll come back, this would be swiped off, I'll come back to this part. Second line would be executed over here. What would be the second line? Second line is print na comma c. What is c over here? The c is b over here. What is a over here? A is a over here. What is n over here? N is 2 over here. So I will write 2a to b, right? Then I will make the third recursive call. I would make the third statement, not the third recursive call. I would execute the third statement. And what would be the third statement do? Third statement is like A, B, C was given to it. In the third statement, B comes over here, A goes in between, and C remains over here. So the first two values are swapped. So over here, CAB, one would be called. And since this is the base case where n is equal to 1, so I'll quickly move that one disk from C to B, right? Right? So what I need to do is I need to move for one. I need to move. What was my base case? If n is equal to 1, just print from A to C. If A is this and C is this, over here A is C and my destination is B. So I would print over here, move it from C to B, right? That is something that we have to do, right? Let's move ahead. This is base case. I'll come back to this part. This is base case. So this the first case is executed, the second line is executed, the third line is executed. So this will also swipe off. My control will come back to this part, right? And over here the second line would be executed. In the second line, what it is printing, it is printing that whatever is coming over here, move that to this block, destination block, and the name of the n is 3. So I have to write something like this, right? Then I would make the third call. In the third call, what I do is, when I'm making a third call or the second recursive call, first two things would be swapped. I'm doing exactly the same I have done with the code, right? You have to be honest with the code. Just keep dry running. You would find the base case. And that's exactly how you would solve Sudoku, you'll solve crossword, or any other recursion with array question or recursion with string question, right? Or any recursion with linked list or recursion with trees question. You just have to follow these steps. So I'm trying to be honest with the code. So third recursive call, the second recursive call is being made. So the first two values will be swapped. It will become BAC2. Now the first recursive call would be made. In first recursive call, these two values are swapped. So it will become BCA1. At 1, there would be a print statement. And what would be the print statement? The print statement would be that move the disk from B to A, right? That is something I have done something wrong. I've done something wrong. No, I've done perfectly correct. Right. It was at B. I'm moving it at A. Perfectly correct. This was base case. I'll come back to this part and I will basically execute the second step. And what is the second step over here? Move B from C. Which disk? Second disk. So move the second disk from B to C. Then I would make another recursive call, the third recursive call. In the third recursive call, the first two are swapped. It will become A, B, C, comma 1. And I would write over here, move 1 from A to C. This is base case. I'll come back to this part. All the three lines are executed. I'll come back to this part. All the three lines are executed. I'll come back to the main block. This is how it should have been executed. And it has printed the desired thing which I needed to print, right? I think I was able to make sense, right? So this is what we have done to execute. This is what we have done to find the base case. This is how we have solved the Tower of Hanoi. right? Still, I have done a very generalized or a very summarized dry run. I would recommend you to go through that 21st May video now also, and I would request you to see how I have mapped this logic with the trees part as well, right? So how I have shown you the areas of recursion, how I have shown you the whole flow of recursion, right? I will still recommend you to go through the video. Over here, I have not shown you the flow of recursion. Like this is the flow of the recursion, which is called the Euler path. This is called the Euler path. And this is the same Euler path which is followed in recursion with trees, right? Still, I would recommend you to go through the videos of, go through the video of 21st May, right? Now, if you have followed this part, I would like to move to the next part where we are talking about how do we learn recursion more, right? How do we learn things better, right? If you have followed up till here, I would like to recommend you, I would like to move to the next part of the webinar, which is how do we practice more questions, right? Just let me know if we can move forward. Any more questions? Anything that you have not understood so far? Just let me know if you have not understood so far. Anything that you want me to revisit or recap, just let me know on that part. Parth, Krishna, Arsh, Shabnam, Shrey, Ishika, Arpan, Ankit. If anybody can give me a quick thumbs up, or if anybody can tell me if I can move forward, then it would be really great. Adarsh is asking a question, how recursive call works when called in a loop. For that, you have to solve a question which has a loop also. It's just that, like here, I have called two recursive calls. In loop, I would call, let's suppose I have kept a loop of 5 recursive calls, right? So let's suppose I made a loop of 5 and it would make 5 recursive call. So exactly what we have done in Tower of Hanoi, exactly something like that would happen. It would make first recursive call, then the answer for the first recursive call would come. It will make second recursive call, third recursive call, fourth recursive call, and fifth recursive call. Exactly the tree diagram or the recursive tree that I am talking about would become something like that. Over here, I have made 2 recursive calls, but if you want to make more multiple calls, you would basically get uh, more recursive call. The tree would become a little bit more complex, right? But you don't have to get into that much amount of depth. You have to just remain at the base level, at the problem level. Assume it for a sub problem. Assume that the answer for the sub problem would come, and then solve it, right? Okay. A lot of people are saying that we can move forward now. So let's move forward. I hope I was able to answer your question, Ashish, right? Others, sorry. Others, I hope I have answered your question. So this kind of a tree would become, you don't have to think about how complex the tree would become just at the start of the problem. You just have to think about problem, sub-problem, try to solve it from the answers of sub-problem. Then slowly and steadily, then you basically, when you dry run it, then you would find base cases. Okay. So Praveen, to answer your questions, how do we decide how many recursive calls we have to make? Right? To answer your question, this is one very good question that we have. So, for example, let me talk about this question, and let me take an example. This is very standard question, which is called coin change, right? So the question that we have over here, right? Ashish, Yash, Praveen, the question that we have over here is called coin change. So let's suppose you have to pay 10, right? You have to pay 10 and you have infinite supplies of 2, 5, 3, 5, and 6, right? You have infinite supplies of this, right? You don't have any dearth, you don't have any lack, you don't have anything less, right? You have infinite supply, right? You have to pay 10 and you have to find the number of ways in which I can pay 10, right? So there are 5 ways. One way is I can basically use five twos and pay, right? That's one way. The other way would be I can take 1 2 1 3 and 1 5. The other way would be I would take two twos and two threes. The other way would be I can take two fives, right? Other way could be I can take two, three, and six, right? So there are these five ways. There are no other ways. You cannot pay 10 by any other way. These are the only ways that we have. Okay, I have done a small mistake over here. This should be 2 2. This should be 2 to 6. Yeah, Parth. This is a lead code question. So I have to pay 10. I find five ways to do this, right? So now let's talk about this part. So we have a denominations array in which I have four denominations and there is some value which I have to pay, right? So what I will do is uh, I would tell it that uh, that I will pay the first amount by 2, right? I would say that I will pay the first amount bit 2, right? So I'm paying the first amount bit 2. If I pay n equal to 10 bit 2, so how much would be left? 8 would be left. So I'm asking that using these denominations 2, 3, 5, and 6, find all the number of ways, find all the count of ways, find all the count of ways by which you can pay 8, right? So it will tell that there are only four ways to pay 8, right? uh, yeah, there are only four ways. Which are those four ways? One way is this, other way is 3 5, other way is 2 6, right? And there is one other way which is 2 3 3. So it will say that there are uh, four ways, right? Right? So there are four ways to pay 8 using these denominations. So it will give me this number 4. What I will do is I'll add 2 in front of all these and I'll pay 10. So all these four ways will become ways to pay 10 if I append this 2 in front of them. So what I've done is I have paid a 2 in the front और फिर मैंने इसको बोल दिया कि 8 का number of ways लेके आ जाओ. ठीक है. So I had to pay 10 and I told him that you find me the answer for 8. The answer for 8 was 4 and I would add 2 in front of this and all these would become my answer for 10, right? Now let's try to pay it with 3. If I started with 3, if I started with 3, would I be able to pay anything? I would not be able to pay anything because you can see over here, none of the ways is starting with 3, right? If I've started with 3, right? If I've started with 3, you would say that there is one way to pay using 3, which is 3 to 5, right? But I don't have to print this way. You have to see how I'm counting over here. I'm counting in the ascending order. एक बारी 2 से पे कर दिया तो उसके बाद दोबारा 2 से कभी पे नहीं किया. This is something that you have to see over here. Once I have paid with 2, I have never used 2 again. Like for example, once I've used 2 and after that I've used 3, I've never used 2 again. So I'm paying in the ascending order. So if I've started with 3, the number of denominations that would be available to me would be 3, 5, and 6. These would be the three denominations that would be available with me. With these three denominations in hand, infinite supplies of these three denominations you would not be able to pay. You would not be able to pay 7. So the number of ways with which you can pay 7 using these three denominations is 0. That's why I would basically say that you cannot pay 10 using these denominations. Now let's try to start with 5. If you are starting with 5, there are only two options, which is one is 5 and other is 6. If you are starting with 5, you are left with 5. And there is one way to pay 5 using denominations 5 and 6, which is using 5 only. I would add 5 के सामने एक 5 ऐड कर दूंगा, it will pay 10. So there are 4 ways to do this and there is one way to do this. So far I have found 5 ways. Now there is one last call that is still left to be made, which is 6, right? Which is 6. So let's quickly make the recursive call for 6. If I've started the recursive call with 6, the denominations which would be available to me would only be 6. With only denominations, with only this denomination 6, would you be able to pay 4? You would not be able to pay 4, right? So this would return 0, this would return 1, this would return 0, this would return 4. So my ways would be 4 plus 0 plus 1 plus 0. So my total number of ways would be 5. Right? This is how we have to solve this question. Over here, I can see that I made 4 recursive calls. Right? That was because it was the demand of the question. It depends on the sub problem that you are trying to solve. Right? Right. Let's talk about some more problems which people are asking over here. So Abhishek is asking that that we can also solve this problem by intertools group by, right? I don't know about this function. Probably this is a library functions. In interviews, you would not be allowed to use library functions. They would specifically tell you that try to solve it by recursion. So something of that kind of a constraint would be given to you. So I would ideally say you should learn recursion. Now, Shabnam is asking that how do we find subproblem if n is dynamic, right? So, if n is dynamic, you have to give me some specific question, right? Like for example, n was dynamic over here as well. So, for example, that question of finding sum of n natural numbers. So, over there, n was dynamic, and I tried to solve this question with n minus 1, right? You have to see some pattern, you have to take some examples, you have to find some patterns, and with the help of those patterns you would be able to find the solution. Try to find some patterns in sample input and sample output. Let's suppose over here you had to pay 10. So you basically told the sub problem, you kept the sub problem as 8, you kept the sub problem as 7, you kept the sub problem as 5. So these were the sub problems that you kept, right? So depending on the sub problem, you would be able to find sub problems. Don't worry about these things, right? Yeah, this is a DP question. This is a DP question which Parth was talking about. What happens in DP? You would learn about DP in a little while, but the first step to solve any dynamic programming question is recursion only. So first, like Kishan Raj was also talking about this fact that please talk about dynamic programming and recursion, dynamic programming, and all these things. So don't worry about these things. Dynamic programming, Kishan, is basically works on 3 steps. First, you have to recursively solve the problem. So solve the problem by recursion. After solving it by recursion, you have to do something which is called as memoization, right? And then after that, what you have to do is you have to tabulate it. Don't worry about these 2 things. These 2 things come under the topic called dynamic programming. First, let's talk about how do we make a recursion strong. How do we make sure that our recursion is so good that we would be able to find the solution to each and every recursion problem which is given to us, right? So over here, you have to let me talk about all the topics that we have, right? So after you have understood recursion on variables, you should understand recursion with arrays and how do arrays work with stack frame. As I was talking about, the variable n is basically was being creating again and again. It was being created again and again. The variable n was being created again and again. So similarly, how does array behave in functions? In one stack frame, in one local function, when it calls to the another local function, how does it behave? That's one thing that you have to talk about. That's that's one thing that you have to focus on. After you understand that, then you have to focus on the fact that how do I break my data structure arrays from problem to sub problem, because you are given an array of size 5. When you will try to solve a problem with recursion and arrays, you would say that find me the answer of the array with 4 size. Try to bring me the answer of the array of size n by 2. That is something that you will do. So you have to see that in the programming language that you are doing, how do we break an array? How do we break the data structure? Similarly, we have other data structures like strings, and similarly, we have other data structures like 2D arrays. How do we work on those things, right? After 2D arrays, there is something called as linked list. We have stacks. We have queues as well. and we have trees as well. Once you get up to trees, all the type of data structures would be completed. Like if you go into tries, it's you can say it's an amalgamation of trees and characters. It's an amalgamation of trees and strings. Priority queues is another form of trees only. Hash map, it's another form of array only. So you have to do recursion questions with these structures, right? With these structures, the first thing that you have to focus on is let me quickly see. So my battery is pretty low. Let me quickly plug in the battery to this part. Okay, otherwise this will uh, go off. So just give me 2 seconds and I'll quickly complete this part, right? I'll quickly plug in the battery part. Okay. Okay, just give me 2 seconds. Okay, now I have plugged in the battery. Now we can talk about these things a bit more and a bit more elaborately. Okay, so what I was talking about, these are the data structures that you have. You have arrays, you have strings. The first thing that you have to do is, how do these data structures behave with functions, right? How do they behave when they are called as a function parameter? How data structures behave when they are called as a function parameter, right? So called as a function parameter. You have passed a array or you have passed a string. How does it behave in the function calling mechanism, right? So that's the first thing that you have to do. Then the second thing that you have to do is you have to see how can we break a problem into the sub problem, right? So problem to sub problem, how can we break a problem into sub problem? How can we break a bigger version of the data structure into smaller version of the data structure? How can we do that, right? That is something that we have to talk about, right? Okay, so once you answer these two problems, then you are ready to start with that data structure, recursion with that data structure, right? So after you're done with this part, then you have to just practice. There is nothing else that you can do. So let me talk about a few places where you can practice, few curated places where you can practice. So one place that we have recently worked upon, one place that we have recently made is Code Studio. So if I take you to this Code Studio part, then I can show you that at this place, we have added interview experiences, practice interview problems, and over here you can categorically select recursion and you can work on it. Let me quickly show you this part to you. And then I'll talk about lead code as well. These are two platforms which I really admire. So I would quickly talk about these parts and then we can basically, then we can talk about other questions that you are asking, right? The Parth is asking one question, right? And Pramod and Shabnam are also asking some questions. So over here, I can see that there are some interview experiences and there are practice interview problems. And over here, I can see there is a block which is made for recursion and backtracking. Over here, you can see there are a lot of questions, right? And like the question pair and sum, that's one question which is given to me, right? And over here, I'm given an integer array. Let's see the question, right? Already they have given me an integer array of size n. and they have given me an integer s. I have to return all the list of pair of elements such that some of those elements, uh, uh, like I have to find all the pairs whose sum is equal to s, right? You can practice it over here. If you're not able to solve it, the solution block is over here, right? So if I see the solution, you can see the approach and the approach to which is given quite elaborately, and you can see the solution over here as well, right? Python, and you can find Java solution as well. So you can see these things over here, right? So that's why I say that this is pretty comprehensive platform. You can use this platform. Apart from that, there is one other platform that you can use, which is Lead Code. So Lead Code is another platform that you can use. But the point that I want you to focus on is that before starting with recursion with arrays, try to do these two parts, right? Try to do these two parts. What are these two parts? That how data structures behave when they are called as a function parameters, and how do I break my data structure? How do I break it into from a larger stack, from a larger subset, and how do I break it into a smaller part? Right? These two questions are very important, right? Right. Okay. Apart from these, please tell me if you have any other questions. Okay, so Pramod was asking that all the recursion problems, can they be broken down or can they be solved by divide and conquer? Uh, you can kind of say that part, that I'm not doing exactly divide and conquer. What happens in divide and conquer is basically I tell somebody to bring the answer to the half part, and I tell somebody to basically bring the answer to the other half part. It's not exactly divide and conquer, but you can say that I'm dividing my problem into smaller parts, right? And then I'm basically asking it to bring the answer for each smaller part. And from that, I'm building my solution. Kind of something like it looks like that it's the definition of divide and conquer only. So you can say that it's following the divide and conquer paradigm only. Okay. 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 So Shreyansh is asking a question that create binary tree using in order and pre-order. Can you explain how recursion works on it? I think we cannot directly jump to that question. It's a pretty, you can say it's a pretty first class or second class question in trees lecture. So trees is something which is coming uh, quite at the bottom of the list of data structures that I have written over here. So I cannot directly go to that part. But I hope you have understood how you should focus on trying to encounter the problems of the recursion with trees. Don't try to go directly to recursion with trees. First understand properly how recursion with trees works, right? And for that recursion with trees, the prerequisite would be my 21st May video, the Tower of Hanoi's dry run, elaborate dry run. In that I have explained you what in order, what pre-order, and what post-order exactly means. So I would recommend you to go through that video, right? Apart from that, any other questions? So Shivam is asking that please discuss questions of Ninja Hire 2. Don't worry about those questions. The test which is happening tomorrow, the solution would come for those questions. Don't worry about that part. How stack works in Python? Stack is something which is language agnostic, right? It is language agnostic. It is not dependent on the language. It's not how it works in Python, how it works on stack is something which is basically it's a data structure, right? Similarly, arrays is not something how it works. How it works in Python or Java, right? Arrays is something, it's a contiguous block of memory, right? It's how you access using that memory, how you access arrays using that memory. It's only the syntax which changes. The things that happen in the back end, they don't change. Yeah, how the architecture is written, it doesn't change. So Krishna is asking that are you aware about the solutions of the Ninja Hire 2. Yeah, the solutions of the Ninja Hire 2, you can quickly figure out that part. Yeah, yeah. Okay, okay. So Krishna, in the Ninja Hire, what you can do is, let me quickly talk about Ninja Hire, and you can see over here. Once you go to the event section, and once you go to the Ninja Hire part, and once you go to the classroom, you can see things over here. And in the mock test, you can find like the pattern part over here, right? If I talk about MCQs are not elaborately explained, right? Only the correct answer to the MCQs is given. It's not elaborately explained. But when I talk about patterns, you can quickly go to this solution block which is given over here, and you can find the solution over here, right? So this is something that I wanted to talk about, right? So if you're not able to implement, to answer the question which Vineet is asking, if you're not able to solve problems with searching and sorting, if you're not able to come up with problems, do more practice, solve more problems. That's the only advice that I can give you, right? Divide problems on the basis of specific topic. Like suppose, let's start with recursion with arrays. Go to lead code, go to the tab, go add a tag which says arrays and recursion, right? Add these two tags over there. You would get problems which specifically work on recursion with arrays, and you would be able to solve them, right? Learn about recursion with arrays. Only learn these two things, right? How data structures, how that particular data structures, in our perspective, in our particular part, I'm talking about arrays. So how arrays behaves when it is called as a function parameter in your programming language, and how do you break it from problem to sub problem part that we have talked about in this webinar at so much length, right? So just learn these two things, start solving easy questions. Slowly and steadily you would move to intermediate problems. Slowly and steadily you would move to hard problems. One thing you are learning, you would not be able to learn for the first time. You would not able to learn it for the second time, for the third time. At the fourth time, you would understand it, or probably at the 10th time, you will understand it, what exactly it's trying to say, right? The only thing that I want to tell you is don't give up, right? The basics are pretty clear. In the webinar today, we have discussed the basics, and we have discussed the next steps. Just follow the next steps. Go to lead code, tag the problems, see the problems according to the tagging, start with easy problems. Slowly and steadily you would be able to solve problems, right? They have a discussion button, they have a discuss button. People have written very good they have written very good posts over there. Go through those posts, find so many other ways to solve that problem. If this is the problem that you have in your hand, try to solve it through this way, try to solve it through this way, try to solve it through myriad ways, try to solve it through multiple ways. That's how you understand that problem. Spend a little bit of time with that problem, right? You would be able to solve more problems, right? Okay, I would be able to take this last question, where Harpal Singh, the user with the username Harpal Singh, is asking, how do we work with spaced repetition? How do we work with, let's suppose I've solved a problem today and then I've given a gap of 2 to 3 days. How do I work with that? Right? It has been 2 3 days, and then basically another problem comes to us, right? I'm solving another problem. So how do we make sure that the knowledge remains fresh to our mind? How do we make sure that it doesn't become stale? The only way to do is, whenever you're solving a problem, make notes. Create a problem notebook, make notes, write elaborately. Whenever you are, let's suppose there has been a gap of 2 3 days, whenever you are basically solving a new problem, starting afresh, revise it before, quickly skim through the notes, right? For each problem, take 2 3 notebook pages, and in that, elaborately write about that problem that you have solved, right? Okay. uh, Parth is asking how many problems we should solve in a day. Part, to answer your question, it doesn't depend on the quantity of problem that you're solving. Focus on the quality of the question that you are solving. So let's suppose if you are solving 5 problems a day, make sure that you are understanding it properly. Like the way we have solved 3 problems today, try to make sure that you are understanding them properly, right? So there is one question that Ujjwal is asking. Let me take that problem. Let me stop sharing and let me take this problem that Ujjwal is asking. And this is one problem which is faced by a lot of people. So the problem is that I'm able to solve recursion problem. I'm able to come up with the logic, but then I'm not able to dry run this part, right? So for dry running the part, I would emphasize on this part again and again. You have to make sure that you understand how the data structure works, how the data structure works in the memory. Like for example, I can see in the stack frame that n equal to 5, when it called to the other part, when it called to n equal to 4, then a local variable was made, a fresh memory was allocated. N equal to 5 didn't had any relation with n equal to 4, right? And then n equal to 4 made a recursive call to n equal to 3. So local memory blocks were created. They didn't had any relation, right? But when we talk about arrays, there is only one memory block of array. And even if you are going from one function to another function to another function, all the changes are made to the same memory block. That is something which is very important. Memory implementation of the data structure, which is very important. How is your data structure having a memory print? How it is functioning in the memory, right? So that is something which is very important. I hope once you do that, you would be able to understand the point that I'm trying to make over here. You would be able to understand, you would be able to do dry run efficiently, right? Okay, so focus on the memory implementation. I think the webinar was helpful for you. Thank you everyone for joining. Still, we have more than 100 people, and it has been more than 1.5 hours. Okay, so thank you, people. Thank you for joining. I hope I would call it a day. Okay, okay. If you have any more questions, feel free to ping me at navdeep@codingninjas.com. Let me quickly share my email ID so that if you have any questions, you can ping me on this email ID. If you have any question, feel free to ask me over here, right? I will try to share some notes as well, but on the 21st May video that I was talking about, I've already shared some notes over there on recursion. So I would ideally recommend you to go through these notes. As you can see over here, there are some notes over here. Where have those notes gone? Uh, I think the notes were shared, right? Yeah, yeah. So over here, the notes are shared, right? So this is the place where the notes are shared. Okay. I would add it in the description over here as well. Yeah, this is the link to the note. Yeah, this is the link to the note in the description. I would add it into our description as well. Whatever notes that I have, I'll add it to our description as well. Okay. Thank you, people. Thank you. Okay. Okay. Bye bye.